All right, hey guys, welcome back. So, just so you guys know, I'll probably put a post on this too. But my fiance's daughter caught COVID over Christmas, so I am quarantined at home until the end of this week. So we'll see how I'm gonna try to do the videos the best I can with what I have here at home. And if you guys have questions, as usual, remind text me or get in the office hours or whatever. Okay. All right, so we're going to start Unit 5 with the notes for significant figures in scientific notation. And I'm actually going to start on the back page, the second page, the scientific notation stuff, because this is review. We've already gone through this, so I'm just going to kind of review. I'm not even going to do all the practice problems and everything on here. I'll do some of them, but I'm just going to do just sort of a little review to knock the rust off and remind us how to do these. So. Okay, so scientific notation is a way to write very large or very small numbers more easily. We know that. How do you put a number into correct scientific notation? The beginning part must be a number between 1 and 10. Then the second part is a power of 10, so times 10 and then to an exponent. When putting a number into correct scientific notation, remember LARS, left, add, right, subtract for your decimal movement. So in other words, when moving the decimal to the left, you add to the exponent the number of spaces moved. When moving the decimal to the right, you subtract from the exponent the number of spaces moved. So let's see down here and do some practice just to kind of go through this. So if you have a number of 450 million, there is no decimal. So if there's no decimal showing, that means it's a whole number and the decimal is at the end. Okay, so let me zoom in over here. So my decimal's there. Okay, now, I need to turn this into a number, the first part between 1 and 10. Okay, so I'm going to take this and I'm going to move the decimal between the 4 and the 5. So that gives me 4.5 times 10. Okay, so 4.5 is between 1 and 10. And then I'm going to do my exponent part now. Now I move this 1, 2, 3, 4, 5, 6, 7, 8 to the left. So LARS is left add. So I add 8. There was no exponent, so it's just going to be positive 8. Okay. So take a look at B. So we've got this number, the decimals here. We're going to make this a number between 1 and 10. So we're going to move the decimal between the 8 and the 0 here. So we get 8.01. We're not going to round or cut anything off. Then we do the second part, the times 10 to the exponent. We move it 10 to the right. So when you write, you subtract. There was no exponent, so it's going to be negative 10. Okay. 472.05. So again, we're going to make this a number between 1 and less than 10. So we move it to the left. Here, we get 4.7205. That's a number between 1 and 10. Times 10. Okay, we moved it left 2, so left we add, so there's nothing there, so it's going to be positive 2. 4.7205 times 10 to the second. Okay, now, what if it already has an exponent, but we're going to still want to put it into scientific notation? So we're not taking this out. We want to make this into correct scientific notation. Okay, so we're going to ignore the times 10 part at first here. We're just going to look at this. So 2,670. No decimal, so the decimal's at the end. We're going to move it between the 2 and the 6. That gives us 2.67. Now this is a number between 1 and 10, which is correct scientific notation. So times 10. Now we still just do the LARS here. We moved it left 3, so left add. We're going to add 3 to the exponent that was already here. So plus 3. 6 plus 3 gives us 10 to the 9th. Okay, let's do one more of those. 0.0035. We're going to move the decimal between the 3 and the 5. Then do the times 10 part. Now we moved it right 3, so right we subtract. So there's a negative 3 exponent here, minus 3. So remember, -3 minus 3 is actually going to be -6. So 3.5 times 10 to the -6. Okay? In the finished notes that I put up, I'll have the other ones figured out too. So if you want to finish those, you can double check them. Okay? All right. Taking numbers out of scientific notation. So reversing this. The simplest way to kind of think of this is if the exponent is negative, you're going to move the decimal left. In other words, the easy way is if your exponent is a negative, your number should be less than 1. Your final number should be less than 1. Not a negative, it should be less than 1, so a decimal. Okay? If you did it correctly. If the exponent is positive, move the decimal to the right. The number of spaces is the number in the exponent. So here, your final number should be greater than 1. Okay? All right. That's kind of a little check so you know you did it correctly. All right, so let me zoom in a little and we can just do these here. 5.02 times 10 to the 7th. Okay, my exponent is positive, so I'm going to move the decimal right that many times. So I go 1, 2. So I've used up 2 of them, so I need 5 more. If there's nothing else there, you're just going to add zeros. So 502, I moved it 2 to the right. Now I need 5 more zeros to get to a total of 7. So it'll be 1, 2, 3, 4, 5, 6, 7. Oh crap. That's not a decimal. So the decimal will be here at the end. So it'd be, here, I'm just going to rewrite this because I accidentally touched that. So it's 502, 1, 2, 3, 4, 5. Okay. So decimal will be at the end, so it's 3, so it's comma, comma. So it's 50,200,000. Okay, let's take a look at this one. Okay, 9.224 times 10 to the negative 4th. So it's a negative, you're gonna move the decimal to the left. The same number as the exponent, so there's 4. So we're gonna move it left 4, so it's gonna be 1 to get it past the 9. Now, the easy way to do negatives when you're taking them out is you look at the exponent. Okay, so you need a decimal. I'm going to put a 0 in front of my decimal here. You don't have to, but I usually do. So 0 point, decimal, and then whatever your exponent is, you have one less number of, like that you do the number of zeros one less. So it's 4, so we're going to do 3 zeros. 1, 2, 3, and then the rest of whatever's over here. 9, 2, 2, 4. So if you look, the decimal started here, so it was 1, 2, 3, 4 to the left, which is what we want. Okay. All right. So that's the quick and dirty for the scientific notation.